Hi, we're on the second part of 2.8, and that is about absolute value inequalities. So we're looking at the same number line we saw earlier, and we're looking at the people in the lineup who are 3 or fewer units away from 0. So these people are 3 or fewer away from 0, 3 and fewer, and same thing here. And so we've got, I'm just going to put them by their first name. Mara, Israel, or their first letter, Tanaya, and Antoine. And then we're shading the portion of the line. So that's going to be like that. Those are all the people. Oh, Laura too. She's on 0, so she counts too. Okay. The graph that we created right here can be represented with an absolute value inequality, and that absolute value inequality would be absolute value of x is less than or equal to 3. So things that are absolute value less than or equal to 3 would be -1, 3, and 0.5. These guys do not fit in there. And this is going to have infinitely many solutions. Infinitely many solutions, because we can keep having fractions and decimals and as many numbers as we want in between here. And if we were going to write a compound inequality, this would be an and inequality or a conjunction. So remember, when they look like this, there's like something in the middle, that's an and. And then when we have something like this, we're looking for things that are 4 units away or more from 3. So here's our 3. 1, 2, 3, 4. And we want more than 4. So it's going to be an open circle going that way. And then 1, 2, 3, 4, an open circle going that way. So this one, 7.1 works, 7 does not. Open circle, nope, yes, no, and yes. And this one is a disjunction, and that is the same thing as an or inequality. Okay, so moving on, let's see how to kind of straightforward solve these. So if our absolute value is not isolated, then we have to do that first, and then I'll show you the rest of it. So the first one, this stuff in here could be greater than 4, and so that's going to be x minus 3 greater than 4. And then it could also be greater than 4, absolute value of that is the same as less than -4. So let's take a look at that. So here's 4. Anything bigger than this, 5, 6, 7, 8, blah, 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 those are all going to be 1, 2, 3, 4, -4, -5, -6. Those numbers up here that are greater than +4 are going to be down here less than -4. So that's how we have to set up this second inequality, this case 2. We have to make it less than -4. So this is our case 1, and this is our case 2. And so then we just solve, add 3 to both sides, and so we have x is greater than 7, which is what we've got right here. So open circle, greater than 7, and then here plus 3 on both sides, x is less than -1. And so our solution set is going to be using the interval notation here. So -infinity to 1, not included, so we have that soft parentheses, the union of 7 to infinity, like that. And then moving on down, now we've got one where we're working from less than. So our case 1 is going to be 3x plus 8 less than 5, and our case 2 is going to be 3x plus 8, and this time we flip the sign and we make it negative. So subtract 8 from both sides. So we have 3x negative 3, and then x is less than negative 1. I just divided both sides by 3. And then this one, subtract 8. So we have 3x is greater than negative 13. Divide both sides by 3. We have x is greater than negative 4 1/3. And it's okay with me if you leave it as an improper fraction, but when I graph it, I need to think about it as a mixed number to figure out where it's going on my number line here. So I'm going to give myself some tick marks. 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. So from negative 1, and then here's negative 4 1/3, and then we're looking at the stuff in between them on this one because it's less than negative 1 but greater than negative 4 1/3. And so that looks like negative 4 1/3 to negative 1. Okay, let's see. So this one we have to isolate our absolute value. So we're going to do plus 3 on both sides. And so now we have 4x is less than or greater than or equal to 8. And so then our case 1 is 4x is greater than or equal to 8. Case 2, 4x is less than or equal to negative 8. Divide by 4, x is greater than or equal to 2. Divide by 4, x is less than or equal to negative 2. I'm going to leave pretty big spaces because I don't need a lot of marks on this one. 3, negative 1, negative 2, negative 3. And so we're looking at including 2, and we want to be greater than, and we are including negative 2, and we want to be less than. So we've got negative infinity, and then this time we're including it, so we use those hard brackets, union, hard bracket 2, because it's included, and infinity. Okay, go ahead and try 27 yourself, and when you're finished, come back and check your answer. Okay, here's the answer for the last one. So our looks like this. If they're compound inequalities, we're going to put that and in there. And your graph looks like this, all the stuff between negative 2 and 2, and your interval notation looks like this. Okay, make sure that you write down any questions you have for me, and we can talk about them when I'm in class.